All right, take two. The effect of COVID on pollution levels in India. Our project looked at pollution levels in India before COVID and compared them to pollution levels during COVID, and wanted to determine if the consequences of COVID had an effect on the degree of pollution in India. Our hypothesis was that pollution levels during COVID were lower than pollution levels before COVID due to reduced social interaction in communities. We used the pandas module and the NumPy module. The pandas was used to organize the data frame, and the NumPy module was used to perform mathematical operations on our data frame. We dropped any rows null values from the data frame and took the average value across each date for each pollutant, since each city recorded the amount of pollutant for each date. We graphed the values of each pollutant across the entire data set to explore our data, which spanned from January 2015 to July 2020. We created a function to automate the process so we can enter any pollutant and it would generate a graph just like this. We created a user interface where the user could just enter a pollutant and the program would generate a graph. I'm going to hand it off to our member Diamond, who's going to talk about the correlation test we did.
We created a correlation map to describe the relationship between each pollutant. For example, AQI and PM10 had a correlation coefficient of 0.86, suggesting that these two pollutants are highly correlated. We plotted different pollutants against each other to visualize their relationship. We created a function to automate this process as well. After that, we used the Seaborn module to generate a heat map, which would allow us the correlation in a colorful way. Redder values indicate a stronger relationship between two variables, and bluer values indicate a weaker relationship between two values. We split up the data into two categories. The first category consisted of data that was recorded before COVID. The second category consisted of data that was recorded during COVID. To do this, we just checked if the year was 2020. If so, we automatically added it to the data set before COVID. If the year was 2020, we checked if the month was before February, and if it was, that was then added to data set before COVID as well. Otherwise, we would add it to the data set during COVID. We converted both of those data sets to a data frame for better visualization. We used our function to generate a pollutant graph to graph pollutants for both data sets. Specifically, we graphed carbon monoxide, ammonia, nitric oxide, and AQI. We generated a graph to separate data points that were taken during COVID and data points that were taken after COVID. For this graph, we plotted nitric oxide against carbon monoxide.
All right, thank you, Diamond. Now I'm going to hand it off to another one of our members, Ronaldo. Let me get to that section. Here are some graphs we generated. All right, Ronaldo, if you want to go ahead.
Next, for each pollutant, we calculated the average value of the pollutant for before COVID and during COVID. So far, our calculations indicate that the carbon levels in India during COVID were significantly less than before COVID. In addition, the average ammonia content in the air before COVID was more than during COVID. Nitric oxide content during COVID was slightly higher, but AQI content was significantly lower.
All right, thank you, Ronaldo.
We wrote a function in which we could pass in the name of a chemical, its chemical formula, our before data set and our during data set. The function would print the average value of the chemical before COVID and during COVID. Our findings support our hypothesis. We found that for 3 out of 4 harmful chemicals, including carbon monoxide, which is lethal to humans, the average content of these chemicals in the air were lower during COVID compared to before COVID. We believe that this was by people quarantining and staying home to avoid the virus. We created a linear regression model to predict pollutant content in the air based on the day number. Also, we wrote a function to generate a line best of fit for scatter plot data.
All right. Thank you, Ronaldo. And thank you, everyone, for listening and watching our presentation. Okay. All right. That one was good. All right. So I'll get this recording sent to Bernice, and hopefully she can edit and then upload it to our YouTube channel. And I thought that was good. That was great. And thank you all for thank you guys for I know it was kind of short notice, but thank you guys for joining us and then re-recording our presentation. All right, that's it. All right, we can leave now. All right, thanks again, and have a good rest of your summer.